Welcome to DPS Baramulla. This is the video representation of topic separation of components of mixture from chapter is matter around a sphere. I'm your teacher Snow Balloon. Welcome to D. Let us start. Our topic is separation of components of mixture. As everyone knows, mixture contains two or more components. The question here is how we separate the different components of mixture. For that, we have different methods and we will discuss the methods one by one. Our first method is centrifugation. In the method of centrifugation, the centripetal and centrifugal forces are used to separate lighter and heavier components of mixture of two miscible liquids. This process is used to separate very small solid particles from a liquid mixture. For example, milk is the mixture of fat, water, and other constituents. Using the method of centrifugation, most of the fat can be separated from milk. In milk, fat is suspended throughout the milk, which is separated out using the method of centrifugation. When milk is churned rapidly, water, which is heavier than fat, migrates away from the center of centrifuge, while fat is forced downwards the bottom, which is drained out. Look at the diagram and try to understand the process of centrifugation. I use word miscible liquids in centrifugation. What are miscible liquids? We have two types of liquids, miscible and immiscible liquids. Immiscible liquids are said to be immiscible if they are completely insoluble in each other. For example, oil and water. Now, miscible liquids, when two liquids are completely soluble. For example, milk and water. Our second method is decantation. Decantation is used to separate the components from a mixture of two immiscible liquids, such as mixture of oil and water. In a mixture of two immiscible liquids, lighter one and heavier one form separate layer. The lighter one can be decanted after settling of mixture carefully in other container. In the process of decantation, some of the heavier liquids also poured out with lighter one. Therefore, components from a mixture of two immiscible liquids can be separated more easily and accurately using a separating funnel. A separating funnel is usually made of glass with a stopcock with drain pipe at bottom. The heavier liquid which is settled at bottom is drained out from the mixture of two immiscible liquids by opening of stopcock from a separating funnel. Our second method is sublimation. There are many substances which are converted into gas from solid when heated and converted from gas to solid when cooled without converting into liquid. Such substances are known as sublime. For example, ammonium chloride, naphthalene balls, camphor, etc. There are mixture of one sublime and other substance can be separated by using the method of sublimation. For example, the mixture of ammonium chloride and common salt can be separated out using the process of sublimation. For this, the mixture is heated in a china dish. The china dish is covered by an inverted funnel. Cotton is used for plugging the opening of the funnel. After heating, ammonium chloride is converted into vapor and gets decomposed over the inner surface of funnel. Due to cooling, this leaves the common salt in china dish. Ammonium chloride can be taken out by scratching from the inner wall of funnel. Now, chromatography. What is chromatography? Chromatography is a method of separation which works on the principle of travel speed of components of a mixture. This method is used for separating dyes and pigments from a mixture. Ink is the mixture of dyes of different colors. There are many types of chromatography. The dye from an ink can be separated using paper chromatography. For this, a strip of filter paper is dipped in the ink. Particles of dye started rising on filter paper along with water. Different dyes rise with different speed because of different types of solubility in water and go up to certain heights. Applications of chromatography. First is in the separation of colors from a dyes. Second, in the separation of pigments from natural colors. Third, in the separation of drugs from blood for pathological tests. Application. Distillation. The process of distillation is used to separate two miscible liquids. The technique of distillation is based on the difference in boiling points of components of mixture of miscible liquids. Distillation is to separate the liquids which do not decompose even upon their boiling points and should boil at more than 25 degrees Celsius. In the process of distillation, the mixture is heated after keeping in distillation flask. The liquid which boils at lower temperature is vaporized at lower temperature. The vapor so obtained is passed through a tube and gets condensed in a separating container, leaving liquid with high boiling point in the distillation flask. Distillation is used to separate the components of a mixture of two miscible liquids that boils without decomposition and have sufficient difference in their boiling points. The process of distillation is used to purify many liquids such as water. One more method, fractional distillation. Fractional distillation is the process of separation of components of mixture into parts or fraction on the basis of fractional difference in their boiling points. Fractional distillation is done when the difference in boiling points of the components of miscible liquids is less than 25 degrees Celsius. In the process of fractional distillation, a fractional column is used along with distillation flask. Fractional column is a tube which contains glass beads which facilitate surface for the vapor to cool the condense repeatedly. Example, ethanol and water are separated from their mixture using fractional distillation. The boiling point of water is 100 degrees Celsius while the boiling point of ethanol is 78.4 degrees Celsius. Since the difference of their boiling point is less than 25 degrees Celsius, thus they are separated using fractional distillation. One more. Applications of fractional distillation. First is in petroleum, refiners, petrochemical and chemical plant, natural gas processing and cryogenic air separation plants. In oil refiners to separate crude oil into useful substances. In the process of organic juices, in the separation of oxygen, liquid, nitrogen and argon from air. Separation of different gases from air. Air comprises of nitrogen, oxygen, carbon dioxide and argon as major components. Since air is the cheapest source of these gases, thus these are extracted from air at large scale. After liquefaction of air by repeated compression and cooling, Nitrogen, oxygen, carbon dioxide, and argon are extracted using fractional distillation. Liquid nitrogen has boiling point equal to minus 190 degrees Celsius and thus turns into gas first and separated from air. The boiling point of argon is minus 186 degrees Celsius, therefore it is extracted after nitrogen. The boiling point of oxygen is minus 183 degrees Celsius, thus it is collected after the extraction of argon. Carbon dioxide turns into solid at a temperature of minus 97 degrees Celsius, therefore it is removed while air is put under liquefaction. A last method is crystallization. Crystallization is a process that separates a pure solid in the form of its crystals from a solution. The crystallization method is used to purify solids. For example, the salt we get from seawater can have many impurities in it. To remove these impurities, the process of crystallization is used. Crystallization technique is better than simple evaporation technique as some solids decompose or some like sugar may get charred on heating to dryness. Some impurities may remain dissolved in the water solution even after filtration. On evaporation, these contaminate the solid. Applications: purification of salt that we get from seawater, purification of crystals of alum from impure samples. Thus, by choosing one of the above method according to the nature of component of a mixture, we get a pure substance. So this was all about separation of components of mixture. Thank you. Stay safe.